Hi viewers, welcome to my channel. This is Rekha Venkateshwarlu, Assistant Professor of Physics, Government Degree College for Women, Nalgonda. In the present class, now I am going to discuss the topic gradient of a scalar field. This is BSc Physics first year, Mechanics and Oscillation paper, Unit 1 syllabus. The contents of the present lecture are, we will discuss about the del operator, then after the definition of gradient of a scalar field. After that, the derivation of the gradient of a scalar field and expression for the gradient of scalar field in Cartesian coordinates. After that, we will solve the problems based on the gradient of the scalar field. Lastly, we will see the conclusions.
Yes. First, let us discuss the del operator once again. What is the del operator? In the last class, we discussed about this. Del is a differential operator. Mathematically, it is expressed as del bar equal to I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Okay, it is a vector. So that's why I have written here arrow mark. And also you can observe that it is in the terms of I, j, k, I cap, j cap, k cap. Okay. It is a differential operator. It is also called as nabla or del operator. Its magnitude has no meaningless, right, sir? Now, this can be operated either on scalar field, that can be operated either on scalar field or vector field. Vector fields. Okay, right. If the del operator is operated on scalar field S, we write it as del bar S. That is called as grad S. That is the gradient of scalar field. Gradient of scalar field that equal to I cap dou S by dou X plus J cap dou S by dou Y plus K cap dou S by dou Z. Dou S by dou Z. If it is operated on vector field, it is operated on vector field del bar dot a bar. We write it as del bar dot a bar, where a bar is vector field. This can be written as dou ax by dou x, dou ax by dou x plus dou ay by dou y plus dou az by dou z. Dou az by dou z. Okay. It is also operated on vector field in another form, del bar cross a bars. It is called as curl of a bar. Curl of a bar. That equal to, we know for a bar cross b bar, determinant I, j, k, ax, b, ax, ay, az, bx, by, bz. So like that, we can write here del bar cross a bar as I cap, j cap, k cap, del coefficients dou by dou x, j coefficient dou by dou y, k coefficient dou by dou z. Here ax, it is ay and az. So del bar dot a bar is called as what? This is called divergence of a bar. Divergence of a bar. Del bar cross a bar is called as curl of a bar. Curl of a bar. Del bar S is called as gradient of S. Grad of S. Here S is the scalar field. The grad of S, that is the vector. The gradient of scalar field represents a vector. Divergence of the vector field always is scalar, because here we are doing the dot product. The curl of vector field, del bar cross p bar, the cross product of any two vector is a vector. Hence, it is very clear that curl a bar is a vector, divergence of a bar is a scalar, Grad S is a vector. Gradient of scalar field is a vector quantity. Divergence of the vector field is the scalar quantity. The curl of the vector field is a vector quantity. Right. Now, so what is the gradient of scalar field? Let us discuss now. Okay. If you want, you can take the screenshot. 1 minute. Right. Sir. Okay. So first, uh, let us define the gradient of scalar fields. Gradient of a scalar field. Okay. So before that, try to understand this figure. I'm drawing the figure. Simultaneously, you have to draw the figure. Okay. This is a level surface S1 in the scalar field. It is another level surface S2. Okay. Here, uh, as I told you that on the level surface, at every point, the scalar physical quantity value remains constant. So on this surface, on the surface S1, at every point, the scalar physical quantity value is the same. Similarly, on the another level surface S2, at every point, the scalar physical quantity value is the same. Suppose if you take this is the gravitational field, on this surface at every point gravitational potential is the same. On this surface, the gravitational potential is some other value that is constant at every point. So here on this surface, the scalar potential value yes. On the surface S2, the scalar potential value S plus ds. Here I have taken two level surface very near. This is the S, here S plus ds. On the surface S1, at every point, the scalar potential value S. On the surface S2, at every point, scalar potential value S plus ds. Okay, sir. Now, so with respect to origin, the position vector of A bar, I am writing it as R bar. Okay. So position vector of B bar is R bar plus dr bar. Okay. So I am writing here OA bar, position vector of A bar is OA bar equal to R bar. Position vector of B bar, point B, OB bar equal to R bar plus dr bar. Then we can write AB bar is equal to OB bar minus OA bar. Okay. So that equal to what we get here, R bar plus dr bar minus R bar. Okay. Plus R bar minus R bar cancel. So that gives dr bar, sir. Okay. So AB bar equal to here dr bar. The angle BAC or angle CAB, say theta. This is the theta. So then consider the triangle CAB. In that, take cos theta. Cos theta equal to adjacent side AC by hypotenuse AB, sir. Okay. From that, AC is equal to, we get AB cos theta. AC equal AB cos theta. This AC I am writing it as DN, sir. DN. So here dn is equal to AB. Already we got dr cos theta. Dr cos theta. Or you can write it as dou n is equal to dou r cos theta. This is equation 1, sir. Say equation 1. Okay. So what I am doing here? So in the triangle ABC, I consider cos theta. Cos theta equal to theta adjacent side AC by hypotenuse AB. From the taking cross multiplication, AC equal AB into cos theta, but AC equal to here dn, that equal dr cos theta, or dou n equal to dou r cos theta. Equation 1 7. Now, so I'm writing the rate of increase. So on the surface S1, what is the value of scalar potential S? On the surface S2, at every point, the scalar physical quantity value, how much? S plus ds. Now, as we move from surface S1 to S2, the scalar potential value is changing. Therefore, I'm writing as the rate of increase, the rate of increase, the rate of increase in S at A is equal to, in which direction? In AB direction. In AB direction, okay, in AB direction is given by, that equals to, what is that? Dou S by dou R, sir. Because in the figure AB is equal to what, sir? dr. సో ఏ నుంచి బికి పోవటంలో ఎస్ లో వచ్చేటువంటి ఇంక్రీజింగ్ రేట్ ఎంత? సో ద రేట్ ఆఫ్ ఇంక్రీజ్ ఇన్ ఎస్ along the direction of AB, that is I am writing here, that is dou S by dou R, sir. Similarly, the rate of increase in S at the point A in AC direction, is given by, since AC is equal to dou n, this would be dou S by dou n, sir. Dou S by dou n. Okay, dou S by dou n. Say this is equation 2. This is equation 2, sir. So from equation 1 and 2, we can write from 1 and 2. Okay, you consider dou S by dou n, that equal to dou S by, but dou n equal from equation 1, what we have? That is dou r cos theta. Okay, that is substituted here. From this, you write dou S by dou r as the subject. Dou S by dou r equal to dou S by dou n into cos theta. This is, you say, equation 3. Here dou S by dou r value depends on cos theta. For what value dou S by dou r value would be maximum? Cos 0 equal to 1. For theta equal to 0, then cos 0 equal to 1, then dou S by dou r becomes maximum. So that is I am writing here. Dou S by dou r would be maximum for theta equal to 0 degree. So then dou S by dou r maximum equal dou S by dou n. So this represents the magnitude of the gradient of the scalar field. The magnitude of gradient of scalar field, dou S by dou r maximum. So with this, we can define the gradient of the scalar field. How? The maximum rate of change of scalar field. The maximum rate of change of scalar field at a point on the level surface. The maximum rate of increase of the scalar field at a point on the level surface. So in our figure, you see the figure, at the point A, theta equal to 0 అంటే అర్థము AC డైరెక్షన్ లో అని అర్థం, అంతే కదా. theta 0 అంటే AC డైరెక్షన్. హియర్ AC is perpendicular to the surface S1. అంటే నువ్వు ఏదైతే లెవెల్ సర్ఫేస్ కన్సిడర్ చేస్తున్నావో ఆ లెవెల్ సర్ఫేస్ కి పర్పెండిక్యులర్ డైరెక్షన్ లో ద రేట్ ఆఫ్ చేంజ్ ఆఫ్ స్కేలర్ ఫీల్డ్, ద రేట్ ఆఫ్ ఇంక్రీజ్ ఆఫ్ స్కేలర్ ఫీల్డ్ అనేది మాక్సిమం ఉంటుంది. నువ్వు ఏబిబి డైరెక్షన్ లో కాకుండా పర్పెండిక్యులర్ ఆర్ నార్మల్ డైరెక్షన్ లో ఎస్ లో ఉండేటువంటి ద రేట్ ఆఫ్ చేంజ్ అనేది మాక్సిమం ఉంటుంది. సో ఆ మాక్సిమం రేట్ ఆఫ్ చేంజ్ ని మనము గ్రేడియంట్ ఆఫ్ స్కేలర్ ఫీల్డ్ గా డిఫైన్ చేస్తాం. కాబట్టి డెఫినేషన్, ద మాక్సిమం రేట్ ఆఫ్ చేంజ్ ఆఫ్ ఇంక్రీజ్, the maximum rate of change of scalar field, or the maximum rate of increase of the scalar field at a point on this level surface. ఏ పాయింట్ వద్ద నేను ఇక్కడ నేను ఏ పాయింట్ గురించి మాట్లాడుతున్నాను కాబట్టి, సో ఈ లెవెల్ సర్ఫేస్ మీద ఏ పాయింట్ వద్ద నార్మల్ డైరెక్షన్ లో ద మాక్సిమం రేట్ ఆఫ్ చేంజ్ ఎంత ఉంటుంది. సో మన ఇక్కడ నేను పై వైపు తీసుకున్నా కాబట్టి ఇంక్రీజ్ అంటున్నాను. అదే S2 లెవెల్ సర్ఫేస్ కింద తీసుకుంటే డిక్రీజ్ అవుతుంది. కాబట్టి జనరల్ డెఫినేషన్, the maximum rate of change of scalar field at any point on the level surface is defined as the gradient of the scalar field. So therefore we write it as, how we are writing, grad S, that is represented as grad S is equal to, that is del bar S equal to dou S by dou N. So here already we got the magnitude. How much that maximum value, dou S by dou R maximum equal dou S by dou N. This is the magnitude into n cap, where n cap represents the direction of the gradient. N cap is the drawn drawn on the level surface. Okay, n cap is the unit vector drawn on the level surface. So grad S is equal del bar S, that equal dou S by dou N into n cap, where dou S by dou N is the magnitude of the gradient, n cap represents the direction. అంటే ఏదైనా లెవెల్ సర్ఫేస్ మీద మీకు మాక్సిమం రేట్ ఆఫ్ చేంజ్ ఇన్ ద స్కాలార్ ఫీల్డ్ ఉండాలి అంటే దానికి నార్మల్ డైరెక్షన్ లో ఉంటుంది అనేది మన ఇక్కడ ఎన్ క్యాప్ ఇక్కడ రిప్రజెంట్ చేస్తుంది. ఓకే సార్. సో దీన్ని మనం కార్టీజియన్ కోఆర్డినేట్స్ లో హౌ టు ఎక్స్ప్రెస్. సో దిస్ గ్రేడియంట్ ఆఫ్ స్కేలార్ ఫీల్డ్ కెన్ బి ఎక్స్ప్రెస్డ్ in Cartesian coordinates if the scalar field S is the function of xyz, where xyz are independent variables, right? The scalar field S is the function of xyz, sir. Okay, then you consider grad S dot dr bar, that equals to grad S. Already we got the expression dou S by dou N into n cap dot dr bar, okay, dou S by dou N into n cap dot dr bar. This is equal to dou S by dou N a bar dot b bar, formula a b cos theta. Here modulus n cap, that is 1 because unit vector, modulus dr bar, that is dr cos theta. Okay, this is equal to dou S by dou N, but dr cos theta equal to, we have, what is that, dou N, that equal to dou N. So dou S by dou N into, this is dn, dr cos theta equal to dn. That gives dou S by dou x into dx is ds. This is equal to ds, dou S by dou N into dn equal to ds. Say this is equation 4. Okay, since S is the function of xyz, ds can be written as ds is equal dou S by dou x dx plus dou S by dou y dy, dou S by dou y dy plus dou S by dou z dz. So this can be written as I cap dou S by dou x plus j cap dou S by dou y plus k cap dou S by dou z. Okay, dot dot I cap dx plus j cap dy plus k cap dz. K cap dz. Dot product simply. If you do the dot product again, you will get the previous expression. Ax bx plus ay by plus kz bz. Okay. So dou s by dou x into dx plus dou s by dou y into dy, dou s by dou z into dz. మళ్ళీ సేమ్ ఇదే ప్రీవియస్ ఎక్స్ప్రెషన్ వస్తుంది. కానీ ఇక్కడ మనం ఇంతకు ముందు ఈక్వేషన్ ముందు ప్రీవియస్ ఎక్స్ప్రెషన్ దాన్ని రెండింటిని మనం కంపేర్ చేస్తే, సో వాట్ ఇస్ దట్? ఈక్వేషన్ 4 లో గ్రాడ్ ఎస్ డాట్ డిఆర్ బార్ ఈక్వల్ టు డిఎస్. సో దిస్ ఈజ్ ఈక్వేషన్ 5 అన్నాం. By comparing equation 4 and 5, it is very clear that grad s is equal to ఏముంది I cap dou s by dou x plus j cap dou s by dou y plus k cap dou s by dou z. Okay. So grad s ని మనము del bar s గా రాస్తాము. Del bar s is equal grad s, that equal I cap dou s by dou x plus j cap dou s by dou y plus k cap dou s by dou z. ఇప్పుడు s ని మీకు అవుట్ సైడ్ రాస్తే I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z of s. Okay. So here the del is an operator that is operated on s. When it is operated on s, we are getting the gradient. Okay. When the del operator is operated on the scalar field, we get grad s, that is del bar s. That expression is I cap dou s by dou x plus j cap dou s by dou y plus k cap dou s by dou z. Right, sir? So what is the physical significance of the gradient of scalar field? The gradient of the scalar field is always a vector, number one. The gradient when the del operator is operated on the scalar field, so here the scalar field is converted into the vector field. When the del is operated on the scalar field, that is converting into the vector field. So that type of vector fields are called lamellar vector fields. Okay. The gradient of the scalar field. If any scalar field is expressed as the gradient, that vector, so whatever the vector we are getting, that vector is called as lamellar vector. This is the significance. Lamellar vector. Okay. By doing the operation of the del on the scalar field, we are getting the vectors. So when the del is operated on the scalar field, the scalar changing into the vector, right? So that type of vector is called lamellar vector. Lamellar vectors. Okay. So based on this concept, finally, again I am writing the expression grad s del bar s is equal to grad s. That expression we got, what is that? I cap dou s by dou x, I cap dou s by dou x, okay, plus j cap dou s by dou y plus k cap dou s by dou z. So keeping these points in your mind, let us solve some problems based on the gradient of the scalar fields. Okay. Yes. We know that r bar is the position vector that is expressed as position vector r bar equal to xi cap plus yj cap plus zk caps. So what is its magnitude? Modulus of r bar equal to r equal to under root x square plus y square plus z square. X square plus y square plus z square. Okay. Now the question is find the gradient of small r, where r bar is the position vector and is the problem. If r bar is the position vector, find the grad of small r. Small r is the magnitude, right, sir? So we know r equal to under root x square plus y square plus z square, right? Or r square equal to x square plus y square plus z square. Okay. Now take a grade of r, that equal to, according to our formula, let us write I cap dou r by dou x plus j cap dou r by dou y plus k cap dou r by dou z. Dou r by dou z. ఫస్ట్ ఒక్కొక్క టర్మ్ సింప్లిఫై చేద్దాం. ఫస్ట్ డో ఆర్ బై డో ఎక్స్ ని సింప్లిఫై చేస్తే సిమిలర్లీ యూ కెన్ రైట్ డో ఆర్ బై డో వై, డో ఆర్ బై డో జెడ్. Substituting those values in this expression, you will get the final answer. So now I am taking dou r by dou x, that equal to dou by dou x of, but r equal to what? X square plus y square plus z square whole power of, sir. Whole power of. So simply partial differentiation. It's a differentiation 1 by 2 x square plus y square plus z square whole power of minus 1. We'll get minus of d by dx of x power n into x power n minus 1. So I am applying that. 1 by 2 x square plus y square plus z square whole power minus of into, again, dou by dou x of this bracket term. You will get 2x. Dou by dou x of y square 0. Dou by dou x of z square 0 because partial differentiation. So with respect to x, when we do the differentiation, partial differentiation, where y, z are treated as constant. But 2x వస్తుంది. 2 cancel, equal to x. So this term x square plus y square plus z square whole power of minus of ni denominator lo రాశాను plus of it. So similarly, now you can write dou r by dou y, that would be y by x square plus y square plus z square plus whole power of dou r by dou z equal to, you will get z by x square plus y square plus z square whole power of. Substitute these values in this expression, grad r expression. So then what we get, grad r is equal to I cap dou r by dou x by x square plus y square plus z square whole power of plus j cap into y by x square plus y square plus z square whole power of, okay, plus k cap into z component. How much we got? Z by x square plus y square plus z square whole power of. So here denominator constant, so that is x square plus y square plus z square, x square plus y square plus z square whole power of. Okay. So in the numerator, xi cap plus yj cap plus zk cap. But that is r bar, position vector r bar. But in the denominator value represents what? That is the magnitude of r bar by r. So the answer, the gradient of small r equal to, answer, r bar by r. Gradient of small r equal to small r bar by r. Okay. So this is the method to finding the gradient of the given scalar field. So let us do another problem. Okay, sir. So one more problem. మీకు ప్రాబ్లంలో స్కేలార్ ఫంక్షన్ ఇస్తాడు. స్కేలార్ ఫంక్షన్ వెక్టర్ ఫంక్షన్ అని ఎలా చెప్తారు? మీకు దాన్ని ఓన్లీ వేరియబుల్స్ XYZ వేరియబుల్స్ లోనే ఎక్స్ప్రెషన్ ఉంటుంది, ఆల్జిబ్రిక్ ఎక్స్ప్రెషన్ ఉంటుంది. అయితే స్కేలర్ మీకు ఎక్స్ప్రెషన్‌లో ఐ క్యాప్, జే క్యాప్, కే క్యాప్ టర్మ్స్ ఉన్నాయంటే అది వెరీ క్లియర్. అది వెక్టర్ అని తెలుస్తుంది మీకు. ఫర్ ఎగ్జాంపుల్, ఏ స్కేలార్ పొటెన్షియల్ V is given by 7x plus 3y minus 2z. Question: find grad V. Find the gradient of the scalar potential. So first you write the formula. Grad V is equal to, what is the formula? I dou V by dou x plus J dou V by dou y plus K dou V by dou z. Okay. So this is equal to I cap dou by dou x of that. So dou by dou x of 7x plus 3y, 7x plus 3y minus 2z plus, directly I am writing dou by dou y of that plus dou by dou z of V set. Here we are doing the partial differentiation. Dou by dou x of this you will get 7. Dou by dou x of 3y 0. Dou by dou x of 2z 0. Okay. The second term, dou by dou y of this will get 3 here, 3j cap. The third term, dou by dou z of this. So with respect to z, we are doing the differentiation. Then x and y are treated as constant. Okay. So dou by dou z of this, what you get? Minus 2 into k cap equal to 7 I cap plus 3j cap minus 2k cap. చూడండి ఇక్కడ ఫైనల్ గా we got the vector 7i plus 3j minus 2k, but the given expression is the scalar 7x plus 3y minus 2z is the scalar potential. Okay, here the gradient of the scalar is the vector, right sir? So this is one problem. One more problem. A scalar field is expressed as S is equal to x cube y square plus 4xz. 4xz. Find grad S. Find grad S at point 1, comma 2, comma 3. Now, first you write yes, the given scalar field grad S is equal to formula I dou S by dou x plus j cap dou S by dou y plus k cap dou S by dou z. Okay, equal to I cap dou by dou x of that. So with respect to x, partial differentiation, we'll get 3x square y square because y constant plus j cap into dou y of that, where x cube is constant, y square differentiation 2y, you will get 2y x cube, 2y x cube. Okay, 2